The poles of our warming world are in peril. With each passing year, sea ice cover in the Arctic melts earlier and takes longer to refreeze. Studies have revealed that the sea ice cover here has shrunk by nearly 20% in the past 3 decades. That dramatic change is affecting the ability of many species to survive. The Canadian Foundation for Climate and Atmospheric Sciences recognizes the strategic importance to Canada of Arctic sciences and of research on the cryosphere, the part of the Earth where water is held frozen in the form of snow, permafrost, glaciers, and sea ice. It is here where the dramatic effects of the warming of the Earth's atmosphere and oceans are most rapidly being felt. Northern residents are dealing with the effects of melting permafrost on their infrastructure, sagging roads and buckled runways, damaged buildings, and collapsing pipelines. They are seeing more coastal erosion, less predictable weather, and shifts in wildlife patterns. These and other changes are affecting traditional ways of life as well as health and economic activity. During 2007 and 2008, researchers from all over the world are taking part in the International Polar Year Initiative. The foundation is providing $28 million to stimulate cutting-edge research in Canada's polar and cold regions. These collaborative projects, led by Canadian university-based researchers, examine sea ice stability in the Arctic, the impact of air pollutants on the northern environment, the melting of glaciers, permafrost, and ice sheets, and the nature and effects of northern storms. They also seek to understand climate variability through the ages and to predict future change. On board a specially equipped icebreaker, geological coring missions reach far below the icy waters of the high Arctic to probe the ocean floor, giving researchers a view of the world as it was in the past.
These slices of sediment represent probably a few thousand years of the ocean history.
To scientists, a sedimentary core represents a page from the history book of the Earth, offering an invaluable record of past climate conditions.
It's a way to go back in time, with slices of time representing tens, hundreds, thousands, even millions of years.
Sedimentary cores contain an archive of fossilized microskeletons, chemicals, and ocean salts, providing a unique window into ancient climate conditions, including water temperature, sea ice cover, and the activity of global ocean currents. The climate records held in these sedimentary cores are also being used to test climate modeling programs designed to provide a glimpse into the future.
If a model demonstrates it can reconstruct the climatic and oceanic conditions that existed some 10,000, 20,000 years ago, then it's likely that this model will be good enough and accurate enough to predict the future.
Sediment from the ocean floor is not the only ancient archive available to climate researchers. Glaciers and ice sheets also have a story to tell. In Ottawa, researchers have their own version of a time machine. The main ice vault at the Geological Survey of Canada contains ice cores holding hundreds, even thousands of years of snowfall records.
This segment of core probably contains ice that is 4,000 to 5,000 years old.
These cores were harvested during an expedition to the Prince of Wales ice field on Ellesmere Island that received funding from the Canadian Foundation for Climate and Atmospheric Sciences. The project brought together research teams from Natural Resources Canada, the University of Ottawa, and the University of Alberta.
Well, we have a collaboration with NRCan in terms of the collection of the ice cores, and that's important from our perspective because historically in Canada all the ice coring activity has been done in government and there really is no expertise in the university community. For us to interact with them has created an opportunity for people from the universities to learn what expertise is there in NRCan.
Cores are placed into a specially designed chamber for controlled melting. Samples are bottled and then sent to university laboratories for analysis.
They tell us something about the composition of the atmosphere at the time the snow fell, how much sea salt was present in the atmosphere, how much acid was present in the atmosphere. And all this information we try to relate to past environmental conditions and how they vary over hundreds and thousands of years.
Well, ultimately what we're trying to do is understand how ice cover in the high Arctic has evolved on various timescales, going back, say, 10,000 years, but focusing particularly now on the last 1,000 years and then the last 50 years, when anthropogenic impacts on climate have become much more significant.
While some researchers look to the ocean floor and the ice to discover more about climate variability, others come to Ellesmere Island to scan the skies, studying the effects human activity is having on the Arctic atmosphere. Perched high on a glacial moraine is the Polar Environment Atmospheric Research Laboratory, a year-round atmospheric research facility.
There are very few locations in the Arctic where you can make a really good study of the atmosphere, probably no more than 5, including this one. And this one is the only one in this sector of the Arctic.
The ozone layer helps protect us from the sun's harmful rays by absorbing part of the sun's ultraviolet light before it reaches the Earth's surface. Work at the Peril facility will improve our understanding of the connection between ozone depletion and climate change. A companion facility back at Eureka employs advanced laser and microwave scanning equipment to study cloud formations and the presence of aerosol particles, such as the smoke from distant forest fires and industrial emissions.
The greatest uncertainty in the climate change models presently is probably the contribution of aerosols.
Aerosols, like smoke and dust, both reflect sunlight away from our planet and trap heat within the atmosphere, making it difficult for researchers to determine their net impact on the environment.
So this is the dust event right here.
The observations made at the various research stations are integrated with other information from satellites to create a more complete picture of what's going on in the high Arctic skies.
The separate instruments themselves provide a certain amount of information, but put all together, it allows one to really understand what's going on in terms of the aerosol in this region.
The desert plains of Ellesmere Island are entirely underlain by permafrost. But farther south, the composition of the land is not so predictable. Another study is currently mapping areas throughout the north to determine exactly where permafrost exists and how climate controls its distribution. As these photos of old Dawson City reveal, when a structure is built on permafrost, which later thaws, the effects can be dramatic. Today's structures are raised off the ground to prevent heat transmission into the soil. Oil and gas pipelines are also elevated. Dams are protected from thawing by thermosiphons, poles which draw heat out of the ground. All these measures aimed at mitigating the effects of a warming climate add enormous costs to building infrastructure. Then there are natural hazards. A few years ago, warming temperatures in the Yukon caused the thin cap of permafrost holding this hillside together to melt, causing a massive mudslide. By mapping the current state of permafrost cover and linking this to climate, project leader Professor Anthony Lefkovich's permafrost study will develop a more accurate picture of the current condition of the land, thereby assisting those planning future construction projects in northern Canada. Another project, entitled Storm Studies in the Arctic, or STAR, examines extreme weather events around Baffin Island and Iqaluit.
The Inuit feel that the wind speed, direction, and its variability have all changed. They have traditional knowledge appreciating how the wind varies under certain conditions, and they're telling us that those conditions have actually changed. The wind is becoming stronger.
Project leader Professor Ronald Stewart has just received an email from a colleague traveling in Iqaluit. The cell phone video reveals the kind of havoc violent winter storms can create in the north. The STAR Network examines the effect extreme northern storms have on wildlife and northern communities.
It's not uncommon in the eastern Arctic to have a major event of the order of, once a week. And these storms are as bad, if not worse, than anything else we have anywhere in Canada.
Changes in the world's northern regions have impacts that extend well beyond the borders of any one nation. The warming of Canada's north is already affecting energy supply and demand, weather patterns, air quality, and economic development further south. But it is also opening northern shipping routes and making Canada's seabed resources a target for foreign competitors. More research is essential in order to understand the warming trend and its impacts, and for development of sound policies to mitigate or adapt to the changes, to identify new opportunities, and for public safety, security, and development. As citizens of a circumpolar nation, Canadians recognize the need to be at the forefront of polar research. The projects funded by the Canadian Foundation for Climate and Atmospheric Sciences are adding to the world's understanding of the processes affecting climate change and are essential for the development of strategies to adapt to the impact of those forces on our most northern frontier.
Our home is the Arctic. This is where we should be. The Arctic is a critical part of the entire global system. This is what we should be doing scientifically, and this is our home. We have people living there. We are affected by that. So it's just, to me, it's just essential.
There's a global consequence to what's going on in the Arctic, and therefore there's a sort of global responsibility for those countries that have stewardship over the Arctic to understand what's going on there.
We claim a sovereignty on a substantial part of the Arctic. One could not consider that the nation would not make an effort to contribute to this international endeavor.